Come to Translate, a channel for intelligent and curious people like you who are searching for human sexuality and spirituality in the age of artificial intelligence. And in this channel, we usually try to find the best possible answer to a question. And today's question is, what is a search algorithm and how this algorithm helps or guide a human robot for every kind of efficient movements? Okay, so today we are diving into a fascinating topic in robotics and artificial intelligence. But before we proceed, let me tell you one thing. If you have not subscribed yet, please subscribe. It means a lot to me. And if you have already subscribed, tons of thanks for your support. Secondly, if you have not joined yet in our membership gym, please consider joining just to support it and stuff. So, what is a search algorithm? It's a new technique, isn't it? It's a kind of algorithms, of course. It's a kind of set of instructions that is a popular pathfinding algorithm which is particularly effective for guiding robots, including humanoid robots, of course, our robot partners, through complex environments. It's a combination of Dijkstra's algorithm and greedy based first search, making it efficient and effective. How it works? Number one is start node, number two is open list, number three is closed list, number four is heuristic function, number five is cost function, number six is exploration, number seven is G cost, number eight is H cost, and then comes never evolution, then comes goal test, and finally repeat the set of six to eight again and again. Finally, it reaches the goal. So basically, it is a kind of pathfinding algorithms, isn't it? Because it starts at a specific or specified starting point. Then it just moves forward. It's a very complex process, so I don't want to dive deep into it. How these heuristic functions, sorry, help or it promising paths fast, or how the cost function calculates the actual cost of moving from one node to another. Because in each movement of a robot involves some cost, because there is battery life, there is hardware life, there are a lot of sensors involved, a lot of actuators, that means motors involved. So that's a very complex process. So I don't want to sorry, I don't want to just dive deep into it. Just I want to remind you that it's a very complex process, and it moves from step to step. I just told you, like, it starts from start node and it ultimately ends at the repeating again and again kind of loop, right? Ultimately, the algorithm continues step 6 to 8 until the goal is reached or the open list becomes empty, right? Because it starts from start node, then comes the open list. The list contains nodes that have been discovered but not yet explored. So it kind of starts exploring the nodes. Ultimately, the list is empty, it stops. That means it finds the path. Now, how it works? Basically, obstacle avoidance is the main concern of a humanoid robot. Algorithm can be modified to avoid obstacles by assisting a high cost to nodes that represent obstacles. Obstacles means anything, furniture, bed, chair, table, anything could be obstacles, or other people in a room, crowded room, and a robot starts its journey from one corner of your room and it comes to you. You stand on the opposite corner. So it is avoiding one after another obstacle, and it ultimately finally reaches you by the help of a such algorithm. Because there are terrain analysis, there are dynamic environments, there are energy optimization, there are a lot of things involved in it. Okay, so by effectively guiding humanoid robots through complex environments, a such algorithm basically contributes to their ability to perform tasks such as exploration, number one, search and rescue, and human robot interaction. Any kind of interaction you can imagine of. So that's it today from me. I hope it's a new kind of information that might help you to gain more knowledge about your human robot partner. See you in the next video. Till then, goodbye. Stay safe and take care.